Yesterday we looked at how you determine the equilibrium constant for a reaction and doing an ice problem, determining, with starting conditions and ending conditions, what the equilibrium constant is, and kind of applying it. Well, the next step, or in looking at, is looking at what's called the reaction quotient. And this would be basically determining what the value is, like, of all of the, so if you knew all the concentrations, you would find what's called the quotient. Okay, the quotient for the system at that moment. So not at equilibrium. So Q gives the same ratio the equilibrium expression gives, but for a system that is not at equilibrium. So it's like you're solving for the equilibrium constant, but you know that it's not at equilibrium, so you're not actually solving for the equilibrium constant. You're solving for this quotient, this value. And to calculate the Q, you basically just substitute the initial concentrations of the reactants and products into that equilibrium expression, and you get a value. And what you do with that value is then you compare it to the equilibrium constant. So if the value is equal to the equilibrium constant, then you know that, well, your conditions that you have are at equilibrium. So this reaction is at equilibrium. But let's say you get a Q value that is larger or greater than the equilibrium constant. Well, what that means is that there's more product than reactants at this point, and so therefore equilibrium will shift to the left, and so the reaction is going to go in the reverse direction. So it kind of gives you, determining the Q and comparing it to the equilibrium constant, gives you an idea of what is this reaction going to do? What direction is this reaction going to go in? And then the opposite would be true. So let's say your Q value is smaller or less than the equilibrium constant. Well, that means you have more reactant than you do product right now, and so the equilibrium will go in the forward direction, or will move towards producing more products till it gets to equilibrium. So that's really kind of how the Q is applied, and it's actually pretty straightforward when you're utilizing it, and obviously doing some sample problems and looking at the sample problems in the textbook is going to be helpful in solving that. And I will be in class tomorrow, and we'll hopefully get back to a normal kind of approach in regards to this stuff. All right, we will see you tomorrow.